So over the past few weeks I've been experimenting with different ways to get a print job off the build plate successfully. Here's what I came up with. If you look closely at this part, you'll see it's very similar to things that I've designed previously, but at the same time very different. The part itself has two continuous rotation servo motors, a battery, an Arduino Mini, and an IR sensor. These parts are all co-processed into the print job at the same time. Let's start from the bottom up. The printer starts to print, and you'll see that there are four main components to this job. Two wheels, the main body, and this piece on the right that you'll see in use later. The two wheels in the main body are minimally contacting the build plate. Once the print gets up to a certain level, we can pause the print and place in our electrical system. The first thing I'm going to do is take off this piece on the side, and you'll see how that comes into play later. The servo motors slide in place from the top, and the wheels are screwed into the servo horns from the side. I've left a channel on the side of the print job so that the wires can slide in easily. We can then place the battery box, the Arduino Mini, and the IR sensor in their respective places in this assembly. Now I can place this piece on top of the servo motors and the battery box, and this will both fully constrain all of the components of this system and provide a flat surface for the rest of the print to print on top of. Now that the system is turned on and live, the IR sensor reads the distance from where it is to the top of the printer. You'll notice in my system setup that I've attached white paper to the cover of the printer to make it easy for the IR sensor to detect. Once the print gets up to a certain point, the IR sensor detects how far it is away from the top of the print bed, and the motors activate. Now there's still a lot of ways that I can improve this system and perfect it. I focused a lot on the mechanical design of the system to ensure that it could in fact roll itself off the build plate. One of the drawbacks of the sensing system currently is that it was all experimental. The robot drove itself off the build plate just before the printer finished the print job. To improve the system, we really need to make the code and the electronics a little bit more robust, but this shows the potential of what co-processing can do. Manufacturing and assembly can be merged through this method, and it can make some really amazing things happen. This robot's now not only useful and entertaining on the print bed, but off the print bed as well. Having the sensor in place allows us to expand the capabilities of this robot so that it can be useful off of the build plate. What's important here isn't that we just got a robot to drive off the build plate, rather it's that we can use co-processing and additive manufacturing to produce truly integrated content. This gives us the chance to change what additive manufacturing really means. We can add different components to our print jobs to not just make parts, but to make fully integrated assemblies. Again, if you have any ideas about how we can push co-processing further, please let me know, and hopefully I'll see you soon.